So I will talk about some basics related to R for today, such as like basic operations with vectors, setting, listing, or deleting the variables in there. Or we will generate some sequence in here, and we will kind of compare vectors and sort them. And after that, I just will talk about missing data types and missing data in R, and then help function in R in here. So I assume that you already know these windows on R, and you know how to use them, and you know what is happening when you just go around here. First of all, what I do is that I just go to File, New File, and open an R script. Then I start writing my notes in here, okay? Such as, this is start 291 and lecture 2. Or you can just write your comments on here, on your R console, instead of your scripts. And that this console just allow you to type comments in R and see how the R system responds in here, okay? And by default, you will just see that greater sign in here as I show you, and the console at the beginning of a line, and nothing else is shown in here. So R is just waiting for you to write something in here, okay? Let's say if you just write 10 plus 7 and enter, you will just see the results. Or you can just go to the script on the very left and upper side of your screen. You can just go and type 10 plus 7. And again, when you just Control Enter or Command Enter in Mac, you will see your output in your console, okay? So we can just summarize R like that. This window is my input, and I'm using it for my inputs in here. And this guy, it is named as console. I just use that guy as my output, and I'm going to show the inputs and outputs in here, okay? And the first thing you should do is that just Control S and save your file on your computer. I was planning to write L2, lecture 2. Then I saved something, and if I add a new line in here, it's going to be red. When I save it, it's going to be black in here, okay? And please remember, if you add a hashtag on here, it's just the comments. And if you want to see the working directory in here, you can just write get working directory, and you are going to see where you are now. And so in here, for example, I am in users and Fulia. Maybe you can just check out where you are. And you can also change your directory in here by giving the name in these guys. Just write the name of the folder you want to go, okay? Just folder names in here. It can be your desktop and any file in your desktop in here. Just these are examples. Of course, it's not going to work. And you can just replace them with the name of your folders in here, okay? And if you move to basic operations in R, let's say we will just cover basic operations in R in here. So we can just start with one of the very basic ones. And so when you enter an expression into R console, and when you press the enter key, R will just evaluate that expression. If I write pi, R is going to just evaluate this one and just give me the results and just display it, okay? If the statement results in a value, R will print that value. It's something like print pi. They're just doing the same job, okay? You can just write pi or print pi in here. And please remember that you can use print as to write only one object at a time. If I say pi equals 3.14, it's not going to give me the results because print is just write only one object at a time. You can just try to add semicolon between them, okay? Just write print and print equals. Please remember, for a new line, I should go to the next line to write my new comment. But if you want to write several comments at one line, then you can just add semicolon between that. You have to add this one actually, okay? And just say print 3.14. And you will see that R is going to give this one, or you can add, or you can use another function in here, which is cat, and it's going to give the given data on the same line for you guys. And also we should add backslash and n to go to the next line. Okay, this is much better, I guess, to use cat in this case. And please remember, be careful that cat is just adding a space between each item. Okay, a space between pi and equals, a space between equals and 3.14. And for a new line character is backslash and n, similar to other programming languages in here. And this n is going to terminate the line in here. Okay, but please keep in mind that cat is not able to write or print some compound data, such as matrix or list. There are compound data that generates a matrix in here. I have my matrix from 1 to 9, and the dimension of the rows are 3. Here is my matrix. If you just cat this guy, you will see that R is not able to write that matrix by using cats. Please keep in mind that. And in this case, you can just say print my matrix 1 to 9, dimensions 3. Okay, print is more usable in here. So now I'm going to show you to construct some longer vectors, and we will use C for this one, just C, which is stand for combine. Okay, let me write the first 11 elements of that Fibonacci series in here. I have 1, 1, 2, 3, 5, 8, what was that? 13, and 21, 34, 55, and 89. These are the first 11 elements of my Fibonacci series in here. We can just write like that, and the output is going to be this guy in here. And now, please see that our environment is still empty because we didn't assign anything to an object. Now, we will just assign this guy, okay, this vector, to an object. I want to give a name to it as fib. And now we are adding an assign sign in here. This guy says that I'm just going to give these guys into fib, or write these guys into fib. You see now, in my global environment, I have a value. The name is fib, and this is a numeric vector with 11 elements in it. Okay. Now we can write something by using this fib function and cat. I'm a fib object and cat. I have my cat now. I'm going to say my name is Fibonacci. Okay. And I want to add my vector. Okay. And also 3 commas. And I will terminate the line by using backslash and n. And here is what, in my cat in here, I write my name is Fibonacci, and then we added fib. Instead of writing fib in here, you will see that cat is able to get the values of fib from here. And here is Fibonacci numbers. And then I can continue by using these three commas. And then we terminate the line by using backslash and end. So also, as an example of a vector, which may span the multiple lines in here, we are going to use sequence operator to produce a vector, the integer between 1 and 100. Let's see what I mean. It's always easier to get the idea by conducting an example in R. So this guy is going to just generate a sequence for you guys. This is your operator in here. Very easy to use. And now you see that you just generated every integer between 1 and 100 in this example. And the numbers inside these brackets in here, just giving you the place of the number in here. This is the 40. This line is starting with the 41st element of your vector. Okay, and now we have more than one line as a vector. It's a big vector for us. And now I just wanted to show you guys some examples again in vectors. And let's see that so a vector can contain numbers, strings, or logical values. Okay, but not a mixture. There is no mixture form for vector. Just keep in mind that this is important for us, guys. Okay, this is the most important thing. You can just generate a vector with numbers such as 1, 1, 2, 3, 5, 8, 13 again, Fibonacci. And here is one of my vectors. Or I can even do some multiplication in here, 1 times pi, 10 times pi, something like that one. Or I can even generate a vector with strings. Let's say I love this course, kind of biased comment. Let's say I can see my vector with characters in here, okay? Or it can be a logical value. Let's see what I mean. I can just write true, true, false, false, and I have lots of false. And here is what I have. This is the logical values, but I do not have mixtures, okay? And I will show you how R is going to combine your mixing data set types in a minute. Let's say I'm writing a vector, the name is A, and I'm going to assign some values into A, okay? So I will assign 1 to 3 into A, and when I write A, you will see that it is 1, 2, and 3. And I'm going to generate my B vector again, and it is going from 4 to 6. And when I write B, you will see that I have 4, 5, and 6. And you can use C. Please remember C was combined, like in here, in Fibonacci. You can just use this guy to combine your vectors. Just write A and B. You see now, I have the combine of the outputs of my two vectors in here by using C command, okay? But if you try to combine mixing types in here, let's say I have my A, I have my B, or I can just change my B as a character vector in here. Let's say I have O, D, T, and U. This is a 4-character vector, 4 elements character vector, and you see that this is the output. And if you try to combine these two guys, the A and B, one is numeric. You see that in my global environment, I can see my A as integer, and I can see my B as character in here. Okay, so if you try to combine them, let's say D equals combine A and B, And when I just write my D, you will see that when we try to combine mixing data types, such as number and strings, R is just converting one of them, okay? So in our example in here, in D matrix, R converted all the numbers to strings before creating the vector in here, okay? And there's always some ways to see the class or the mode of your data elements. Let's say if I say the mode D, and I'm able to see what is the mode, which is character for D, or let's say I want to see the mode of pi, and it's a numeric. And when I see mode, it's a character. So we are going to move some basic operations in R now. Let's say I'm going to show you some basic operations in R. So when we perform an operation on two vectors, what R is doing is that, guys, R is just matching the elements of the two vectors pairwise, okay? And it's going to return you a vector. Okay, what does it mean? Let's see what I mean. I have one vector with 4 numbers, 1 and 2. You can just add anything you want, guys. And I'm going to add plus with 0, 1, 2, and 3. And now when I just run this one, you see that R is matching first element with the first one, second element with the second one, third element with the third one, and the fourth element with the fourth one, okay? It's always happening for each operation. I can change it to multiplication, and then it's just doing the same job for me. Or you can add even, let's say, another one, the minus. This is very easy, I guess, for you to catch the idea. Okie dokie. So there's one thing in here we should be careful. If two vectors aren't the same size, okay, they have different sizes in here, and R is still running your commands, okay? It doesn't stop there. It still run your commands, but it is going to just recycle the smaller sequence multiple times. This is very important for us, guys. You can just give 2 different sizes vectors to R to do some basic operations, and R is just recycling the smaller sequence or smaller vector in here. Let's see what I mean. I want to add a vector with 1, 2, 3, and 4, okay? And I'm just adding this vector to 1, okay? Just 1. And let's see what is happening. R is recycling this 1 4 times. And then just adding this vector to that one, to the first one, element by element. And this is same by doing 1, 2, 3, 4 plus 1, 1, 1, 1, okay? When I run this one, the result is still 2, 3, 4, and 5. And the only thing in here is that you can save some time just writing one of them. So again, we can continue with another operations we have in here. 1 over 1, 2, 3, and 4. Again, R is recycling 1 4 times. Or let's say I have 2 vectors. The first one is the one that I know, 3 and 4. And the second one is with the element only with 2 guys in here, 10 and 100. You see what is happening in here? I have this guy with 4 elements. And now the second vector has only 2 elements. and R is just recycling that guy. What is R doing in here is that, let me show you. And it's just adding 10 and 100. And just giving the same guy in here. What else? More vector arithmetic. Let's see. I say one of the vector into V1, 1 to 5, and V2 is going from 10 to 15. Okay, I have V1 and V2. You can just add V1 to V2, and now you still have the results, but R is just throwing a warning message for you guys. Okay, it says that longer object length is not a multiple of shorter object length. Okay, when you see this one, this warning, everything is okay. Your code is working, but please keep in mind that the shorter one is recycled, because we have 5 elements in the first one, but we have 6 in the second one. Then R is adding 1, 1 to here, and it's 16 for us when we do the operation in here. Or you can just say V1 over V2. And again, R is going to give you the result, but it's going to recycle V1 for you guys. Okay. Okay. What else? So we also have character vectors in here, and we can easily use the combine with these characters. Let's see what I mean. I love this course. R is a love at first sight. So I will make you love R for sure, okay? So now I'm able to combine even character vectors in here. And there's one warning for you guys. Please make sure you are complete with your expressions in R. This is very important for us. Let's say I'm trying to find the maximum, or let's say minimum value from 3, 6, and 9. And R is giving me 3 because it's the minimum of these guys. But if I forget one of them, let's see, and R is not going to work, and it's going to add a plus sign. If you see a plus sign in your output, you will see that for sure, I guess, in the future. And that means your comment line is not complete now, okay? You should complete your expression. And also, this is a new feature in R, I mean, relatively new, and it's just adding the error for you guys. When you just go there, the error just pop up, and it said that unmatched opening brackets in here. And now we are going to close your brackets depending on the error message and run again, and R is going to give you the results in here. So I will continue with setting, listing, and relating variables. And please remember, we were able to assign a value to an object. The object is A in here, the value is 7. We assign 7 in A, okay? And you will see that, and I can just write B as 3. You can always play with the results, guys. And then I can generate a new vector, let's say that D, and then I'm able to just get the square root of A to 2 plus B to 2. Okay, we can do some arithmetics in here. And also there are 2 other ways to assign values. One of them is just you can write first value and add assign value to the other side and just write the name of the object. And now your A is going to be 8, but please keep in mind that this is not that common, okay? So I can just write do not prefer. This is not that common in R. We generally add the name of the vector or the object first, then the value, okay? And also, you can use equal sign in here. Now your A is 9. Equal sign is just doing the same job with this operator, with assignment operator in here or assign operator in here. But there is something wrong or something controversial in here about this sign. The equal sign just is easily confused with the test for equality, okay? We are using the same sign in here to test the equality. And also the right word assignment is just too unconventional, okay? And after a while, your code is going to be very difficult to read when your expression is long in here, okay? Generally, I don't use assign sign. And it is not that common in R to use, I mean the equal sign, okay? We generally use this one. But of course, it is, you should know all of them, because when you are reading someone else's codes, then when you see the equal sign, you should know what's happening. If I add 2 of them, it's just giving me logical value. We will talk about it, okay? Because of that, we are not using equal sign. And I'm going to show you the ls function and to see what variables are defined in our workspace. Let's say I just ls, and when I ls, you see that I have a, b, d, fib, v1, v2, v3 so far. And also I can see this guy in my global environment. And also there's something nice in R. You can see the details with str. str stands for structure, okay? And ls_str means just list my objects by giving their structures in this example. So you can see all of them. And there's one thing you should know, but you should be careful while you are using, which is rm function. When you use rm, it is for remove variables or functions from your workspace or erase them completely. When you do that, there is no undo, okay? Then please be careful. And when you just remove, let's say A, okay? You do not have A anymore. List your variables, you will see that you do not have A, it was here before. But please be careful. There is no undo for rm function. And once the variable is gone, it is gone, okay? You are even able to erase all your variables at once. So please see that which variables you have or which objects do you have. I have like 6 of them. And if I want to remove all of them at once, I can say remove. I can give a list to remove, and it's going to be the ones in ls, okay? And when I just list them, you will see I have nothing there because I have removed everything in here. So let me continue with sequence in R. If you write something like this one, let's see. First, let me add a title for this part. I will continue with sequence. And actually we already see that one, but I will give some details. And when I write something like n to m, okay? This is just creating a sequence from n to m by adding 1, something like this one. n plus 1, n plus 2, and it's going one by one until coming to n, okay? This is what sequence is doing in here. Okay, let's start. I can just write 1 to 10. We already know that one. That's easy. But also we can use sequence comment in here. This is just generating a regular sequence for you guys, okay? It's a generic function. And now I can go from 1 to 5 by 2. Okay, I'm going from 1 to 5 by 2. And it's just writing every elements between these two guys, adding 2 for all of them. Okay, by default, if I do not add this by in here, it's just adding 1. This is the default. You can just play with that one. I think so. Please keep in mind that this from and to and by are arguments, and you can always skip arguments. I will know that. Okay, I can just write sequence from 1 to 5 by 2, and it's going to do the same job for you guys. Okay, or you can generate another sequence, let's say from 1 to 100 by 20, and then here you go. And we also have another function, which is wrap for repeat or repetition. Let's say I have my wrap. I'm going from 1 and the times equals 10. 10 times, just repeat 10 for me. Again, you may want to skip arguments in here. Let's say I'm going from 1 to 1. I'm going to write 1 10 times. Okay, this is my repeat in here.
Hocam.
Yeah. So we just zoom in the window. I think your vision is going to be better now. And now we learn how to use wrap, it's for repeat in here. I can again use like 2 100, and I'm just writing 2 100 times. It's a very useful function that you will use, I guess. And now we can go backwards for sequence from 10 to 0. Okay, and it doesn't have to start from 1 or 0. You can just even start from 10 and go to 20 by 1. Okay, and also we can use that one with numeric values, guys, something like this one, 3.5 to 9.5. Okay, and V is something like that. And also there's one thing which is useful. It's possible to specify a length for the output sequence. Let's say you want to generate a sequence from 0 and you will go to 100, and you can even give length out in here. Length out for you guys, just add like 5, and my length is with 5 elements in here, and R knows how to create a sequence with a specific length in here. Okay, and as I showed in here in this example, R is also able to create sequences with fractional increments in here. Let's see what I mean. For my sequence again, I go from 1 to 2, and the length out this time, I'm not good at writing length. It is the hardest word for me to write. You can say 5. Now you see that we have some fractional increments in here. 1, 1.25, 150, 175, and 2. And it's very easy for R. So please keep in mind that to use length out, you do not have to write from or to. If you just write sequence 1 to 2, and it's going to work for you guys, but you have to add length out in here. In this example, you have to length out in here. So if no question is around, I'm going to move to any subtopic.
Hocam.
Yeah.
Hocam aynı anda hem
so we will just see comparing vectors. Sorry guys, vectors now. Yeah. Now this is our if you want to compare vectors, guys, you can just use some operators. And they are going to perform element by element comparison of your two vectors, okay? And or it's going to just compare your vector with a scalar. Scalar is just a one element. Please remember that vector is just the vector with several elements in here. So when you just use that comparing operators like, let's see, like this one, if it is equal, okay, or if it is not equal, these are your comparing operators, or smaller or greater, these are the ones. And the result will be a vector of logical values, which means what? So these are trues and falses we have as logical values as an output. And so each element in here is a result of one element-wise comparison in here. Let's see what we mean. If I write A as 3, okay, and if I ask, okay, R, tell me if A is equals to pi, okay, we are just testing for equality, and it's just giving me false. That means A is not equal to pi, because pi is, remember, 3.14, okay? And also, I can ask if A is not equal to pi, and the answer will be, yeah, the answer will be true.
False.
This is true, because A is not equal to pi, okay? Because A is 3, pi is 3.14. Then they are not equal to each other. And if I say A is smaller than pi, it's going to be true because it is smaller than 1. Or I can ask A is equal or smaller than pi. And then the answer is true. Okay. And I can ask if it is greater than pi, and then the answer is false. So we are just comparing two scalars now, and I also can compare vectors in here. It is also possible in R. We have, let's say, B vector, and I'm going to combine 3, pi, and 4. And after that, I'm going to generate my D vector by using combine. And this is all pi, pi, and pi. I'm using pi because it's easy, guys. And then I have B, which is equal to D. Let's see what's happening now. We have false, true, and false. You see that this guy is just comparing the first elements, which is false, second elements, which is true, and the third elements, which is false again. And if you are trying to compare not equal, then you just have the opposite. Now we have true, false, true in here. And again, we are able to check for B smaller than D, or B greater or greater equals to D. You can just check for everything in here, okay? And also you can just check out for the vector elements and see if they are equal to pi. That means you are comparing each element of the vector against a scalar in this example, okay? And also R has some more useful functions. So if you want to know whether any of the comparisons were true or whether all the comparisons were true, we can use any and all functions, okay? So when we use any in here, this is another function for us, guy. It is just giving a set of logical vectors is at least one of the values true. Okay, we are just looking for any functions, and it's going to return true if any element of the vector is true in here. And if I say any B equals pi, what's going to be the answer? Do we have any value?
True.
Yes, we have at least one of them, okay? And if I say all, This is another function for us, guys. And it's just looking for you the true if all elements of the vector are true. And if I add all b equals pi in here, let's say here is my pi, then you see that we have false, because not all the guys are equal to each other. We only have one of them in here. I'm going to continue with sorting now, guys. Let's generate a vector together by using combine. We have v, and then we are going to combine some guys. Let's see, I'm going 10 to 1. I will add 5 and 2.2. It's up to you guys. You can just generate your vector with whatever values you want. And I have this vector. And if I say sort, which is easy, I can sort all my values. And if I sort v with decreasing true, then it's going to sort by decreasing in here. Okay? Did you get the idea here? I think it's really common and convenient to use. And please, so all in all, what we covered so far, everything in R is an object, okay? So in R, we have 6 basic data types, okay? We have 6 basic data types, which are character, and we have numeric. This can be real, guys, or decimal in here. And let's see, we have integer, and we see logical values. We have logical type of data in here. We may have some complex data types, and also we have raw data size in R. These are the 6 main basic data types in here. And also R just provides many functions to examine the features of your vectors or other objects, like class, type of, length, dim, attributes. All of them can be used with your data. Let's see what I mean. I just generate a vector, the name is X, and I'm going to generate a data mine vector, okay? And when I write X, you see the output. If you want to see the class of this guy, this object, you can just write class. And you see that it's a character. And you will see that the type of is going to give you the same output, then your type is character in here. And when we just ask for attributes, attributes is generally used for functions. And then if I use it vector, it's not giving me anything because there is no attributes for a scalar or for a vector in here. And let's generate a y vector from 1 to 20. I will give you some more examples in here. If you just say type of, it is giving me integer. This is an integer. And if you want to see the length or length of y, then the length is 20. And also you can just change your integer to a numeric by using as numeric. Let's say I want to generate a new vector from y. I will use this guy in here. Please remember the type was integer. And I want to change that as numeric. And now my y, like, let's check out for the type of z in here, and it's a double in this example. It's kind of different. Like if I just ask for class for z, and it's giving me numeric. Type of class is really, really similar to each other, guys. It's giving me very similar or the kind of the object, and class is kind of high level. And when you ask for type of, it is the what is the type of the objects in there, okay? What is the object's data type? And it's kind of low level in here. And also R has many data structures. R has many data structures. You may have an atomic vector, which we have used. You may use list in R. We will see the list. And also matrix, we will see matrix. And also data frame. We will cover data frame. And you may have factors, okay? These are the data structures in R. We have these data structures in R. And your vectors can be two types. This can be atomic vectors or list, but please keep in mind that we are going to refer atomic types in when we say vector for rest of the class in here. We are not talking about list inside vector, but of course we will talk about list separately, okay? Now, after that one, I want to just compute some basic statistics. We will compute, we are going to compute some basic statistics, guys, in here. Sorry, it's my bad. So assume that you have two vectors, which are x and y. We can use some functions to compute basic statistics, which are there. It can be mean, or you may want to check out for the median value, or one of them is standard deviation. But please keep in mind that you should use them with some vectors in here. Okay, let's say x, and we can just check out for the standard deviation of x or variance. Please remember we have another statistics, which is variance, or we have correlation, but correlation is between two vectors, or we have covariance, again, between two vectors in here. So let's see the FIP. Oh, so we deleted, I guess. We are going to generate the vector, the name is FIP in here, 1, 1, 2, 3, 5, 8, and then 13, and then 21, then 34, 55, and 89. This is our Fibonacci. Okay, I have this vector, and if I want to see the mean of FIP, that's easy. I can check out for the median and of the FIB, of course. That's easy too. You can check out for how your data is behaving, okay? You can learn the characteristics of your data by using some statistics. This is the first thing what we are doing when we see the data. Okay, find the descriptives. First thing, see the data, find the descriptives, then move to visualization. Okay, after that, you should just get the visualization, then analysis in here. Okay, don't forget the basic statistics for your data set. Standard deviation and variance. Oh my gosh. Okie dokie. And I can generate another vector. Let's say I have FIB, I have BIF now. I'm going to generate another vector by using my FIB not keep FIB. And this is my BIF now, okay? And now I can easily find the correlation between this guy. You can guess that the correlation is going to be really high. You see that it is 0.95. And also we can find the covariance between FIB and BIF. And this is the covariance between them. Please also remember we have V1 vector, we just used it before, which is 1 to 5, and we have V2, which is 10 to 15, and I can just check out for the mean value of my V1, and also I can recenter my vector. What does it mean? If you want to recenter your vector, you can write your vector minus mean of your vector. This is centering, okay? You see that we are centering around 0. I want to show you something, guys. Please be careful when you are using these functions because they are really picky about the values which are not available, like NA. If your value is not available, then they are not going to work. Let's see what I mean. I want to generate a new vector, let's say fib. This is my new vector. I want to use my fib, and also I want to add an element, a new one, which is not available, which is NA, okay? So let's see the vector, how it is. You see that the last element is NA. So my basic statistics functions are really picky for NA. If I say mean value of fib, you will see that it is NA because I have even one NA in my data and it's not able to find it. If you are thinking that, guys, your data has some NAs in here and you should add something like this one. Okay, find the mean value of my fib, but please remove my NAs. Then you can just say true. Remove my arrays, and R is going to find the mean value in here. Let's continue. And now I want to show you missing data. What if we have some missing data in here, in R? R is friendly, and it's going to help you, of course, when you have missing values, but you should also help R, how you can handle with missing data. Let's generate a vector with some missing values. Let's say what I mean. I'm adding numbers from 1 to 3, and I add one not available value, which is NA. NA stands for not available in R, and it's a missing data for R, guys, okay? And I have my A, 1, 2, 3, NA, and 7. So if I also generate a new vector, which is B, I'm just combine true, false, again, NA, and false. This is a logical vector. It can also include some NA values. So we have a function which is is.NA, and this function just indicates the element of the vectors that represent the missing data in here. And the function, we also have another functions in here. One of them is any NA, and it's going to give you true value if the vector contains any missing values in here. Okay, so let's see what's happening. If I use is NA is something like you are speaking English. Okay, R, tell me if there is any NA values in my data. And if I write a vector in here, you will see that I have false, 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 true, false. Because please remember my A is something like that. I have 1, 2, 3. These 3 guys are not NA. Then false. And I have 1 NA, and is NA is true. And 7 is not missing, and it is again false in here. Okay. And also we have one more function, any NA. We can ask for B, and it's saying true. Is there any NA in B vector? It's something like speaking English again. And the answer is true. Yes, there is one NA value in your B vector. Also, we have IN phi, which is infinity. And we may have positive or negative infinities in our data. If you are familiar with in math, I think you are. For example, 1 over 0 in math is infinity. Then 1 over 0 is infinity for R2, okay? And also we have NaN, which is not a number. It is also available in R. When you write 0 over 0 in math, it is not a number. And it is an undefined value for R2. And the output is going to be NaN. They are kind of different than each other. 1 over 0 is infinity, 0/0 is NaN. If you have these values, then R is throwing some infinity or NaN characters for you guys in here. Please be careful while you are using them. So, of course, R is friendly and it has some help functions for you guys, okay? It is here to help you in here. You can try to see some documentations, table of contents with R. Let's see, I can just write help start. And if you are connected to internet, in help file is going to come here. You have this statistical data analysis tool, and you see that we have some menus, introduction to R, writing R extensions, R data import and export, and we have installations, administrations, and we have reference, and we have even more materials in here. You can just check out for them, guys, okay? And this is a really good, for example, topic, or this is a really good content in here. You can just go and check out for everything. And if I were you, I would cover everything like week by week when we are covering R in the class. Okay, you can see vectors, assignments, and arithmetics, and many more examples and also explanations in here. Just check out, okay? Just check out for them. And if you want to ask for anything in R, you can just use help and write whatever you are asking for. And question mark is just do the same job. They are displaying the documentation for the function, okay? And then you can see them. Let's see, I want to see one of the functions in here. I can write the function name inside and just check for that one. So there is nothing like function name, of course, but instead of that one, you can just mean, and it's going to open the help function for you guys. This is very important for us. And now it's giving you examples and explanations. I generally use the examples at the very end of the documentation and use it there. Let's see, when we write ST, this is a standard deviation. We have the description for this function, okay? And you see that it's giving you NA true is true, then missing values are removed before computation proceeds. And there is only 2 arguments in this function, X and NA remove. And you should give a numeric vector in here, not a factor. And then here is the details, and here is the example. This is the example they provided. And also you can just check out for arguments, and it's just giving you the argument names and corresponding default values of a function in here. Arguments can be used just a quick reminder of the function. Let's say I have my argument for mean, and sorry guys. Let me delete this part. Okay, it's just giving me the function, and for mean, it's just giving one of the arguments. And for ST, we have X and NA remove true in here. And also, if you write example, let's say example for mean, it's going to provide you the examples related to mean in here. I think that's helpful, okay? So before exiting R, so I think this is all I wanted to say help. And about help, I mean, if before exiting R or close R in here, make sure you saved your file, this R file, okay? For example, for my case, I have my stat file. When I go to desktop, I will go and find this stat file in there, okay? But do not save the workspace unless you want to overwrite the previous saved workspace in there. What I mean is that if I just click this quit, is asking me, I'm quitting the session in here. And if you want to save the workspace, I never save workspace. Then I say don't save, okay? And if I save workspace, it's going to save everything in my environment. And when I open back my R, A is going to be this guy all the time now. Okay, please do not save this part, my friend. So I think I'm done for today, and we covered kind of an introduction in R. We see some basic operations in here with vectors, and we set, list, and delete some variables, and we covered sequence in here, and also we compared vectors, and also we sort some vectors in here. And at the end of the lecture, we compute some basic statistics and also covered some missing data. And we repeated how we can use that help function in R, which is going to be very important for us in the future.